So Dr. Thomas Andrillon is a senior researcher, NHMRC ECF fellow, and previously working on sleep mainly. However, upon arriving at Australia, he's trying to connect the sleep research, especially in the dream research, with mind wandering. And this project that we have been doing over the years is to use the EEG and direct probing of the mind wandering, which is also, pioneered by Jonathan. So it's a kind of nice preamble to Jonathan's talk. Go ahead.
Thanks. I feel like a rookie musician warming the room before the arrival of the big star. So here is actually a presentation of some of this work we did with now Jenny and two students, Angus Burns and Tegan McKay, on mind wandering and this connection that was initially unwanted between mind wandering and sleep. So how the lapses of attention could be explained by sleep intrusion during wakefulness. And this idea comes from a recent transformation in sleep research where we came from a vision of sleep that was really an all or nothing phenomenon. So when you're during the day, when you're awake, you're fully awake. So all your brain is displays a wake-like activity. And when you're asleep, you will have a brain that will be globally asleep. But there is growing evidence that actually between this ideal state of complete wakefulness and complete sleep, they can be states that are in between, where at a given time within a single brain, you will see both patterns of activity that are reminiscent of wake and patterns of activity that are reminiscent of sleep. And this can happen during the day with intrusion of sleep during wakefulness, and during sleep, you can have intrusion of wakefulness during sleep. And the idea here is to try to understand how this fluctuation in the physiology will impact fluctuation in cognition and consciousness. So what we wanted to do with this project was to take the physiology and to try to link this fluctuation of the physiology with behavior, but also phenomenology. So not only trying to explain how people behave, but also how they feel. And to do this, we used a quite classical task, so-called the SRT, for sustained attention to response task. We had actually participants doing two variants of this task in a single session. The classical digit SRT, where participants are presented with sequences of random digits, and they're instructed to press a button for all the digits except the digit number 3. So it's a classical go, no go, with lots of goes and a few no goes. We had a variant of this task where we replace digit by phase stimuli to try to entrain the visual ventral pathway specifically. And they had to do the same task. This time the go trails were neutral faces and the no-go trails were smiling faces. So they do this task, which requires sustained attention because you have one stimulus occurring every second, and you have to pay attention to the stream of stimuli. And from time to time, we interrupted participants and we asked them a series of questions. So it's a procedure called experience sampling, where you ask them about their state of mind. And in particular, participants were instructed to indicate whether they were focusing on the task before being interrupted, thinking about something else, so a phenomenon classically called mind wandering. So it can be thinking about what you're doing next, or what you did in the past, or your vacation, etc. And then we added something that's not frequently asked about, the phenomenon of mind blanking, when you can't recall or you were not focusing on anything. So you have this impression of waking up from a state of blank. So we had 26 adults doing this rather long and boring task. And what we observed is something quite in line with previous findings. So in this rather undemanding task, participants were focusing on the tasks only half of the time on average. You can see that there is quite a lot of variability here. And the rest of the time, they were either mind wandering, so about 40% of the time, or mind blanking, about 10% of the time. And in accordance with previous findings, we see that the instances in which they are not focused on the task, so both mind wandering and mind blanking, increase during a block or increase from block to block. So far, something very, very coherent with the previous literature. Now, we were interested in this link between this phenomenology and behavior. And what we did was to look before an interruption in these three different categories. What was the behavior before that interruption? Since it's a go-no-go task where there are lots of goes, the performance on the go trials is pretty good. But participants make a lot of mistakes on the no-go trials because they get carried on and press a button even there if they are not supposed to. And what you can see is that in the case of mind wandering and mind blanking, this propensity of participants to press the no-go button, to press the button on no-go trials is even more increased. What we saw is also an interesting patterns in terms of reaction times. And this time we saw a difference actually between mind wandering and mind blanking, by which during mind wandering, people tended to be faster, so displaying a marker of impulsivity, while in mind blanking, they tended to be slower, so displaying a marker of sluggishness. So as if when they're thinking about something else, they're a bit jittery and they might speed up, while when they're thinking about nothing, they might be potentially less aroused. And it has been proposed actually that mind wandering and mind blanking could be reflecting opposite states of arousal, with mind wandering reflecting a high level of arousal and mind blanking a low level of arousal. However, this picture doesn't quite fit with what participants reported in terms of their vigilance. So we asked them at each interruption how tired they felt, and they declared being more tired in both mind wandering and mind blanking compared to task focus states. And this subjective assessment of vigilance was paralleled by a decrease in the pupil diameter, which is a quite common objective marker of tiredness. So we have both objective and subjective signs that in both mind wandering and mind blanking, participants were feeling quite tired. So we thought that we could actually study the impact of this fatigue on the attentional lapses by using this concept of local sleep. So these local sleep intrusion are really the observation during wakefulness of an activity that is characteristic of non-REM sleep. And this activity is the so-called non-REM slow waves, which are delta waves, so between 1 and 4 Fs. So high amplitude delta waves, which have been shown in both human and animals to correlate with the silencing of neurons. So it's really a moment where your brain will take a pause in a way. And they are called local because they can be either local in time. So in a globally awake brain, you will suddenly see such a wave transiently. So that will be for the local in time aspect, or they can also be local in space. So you will see it in one scalp electrode, but not the others. So how we detect that in practice, it's fairly easy. You take your EEG and you simply filter it in the slow frequency range, and you identify the negative peaks in the signal, which is a way to look at the individual waves. You extract the amplitude of all of these waves, and you plot the distribution of these amplitudes. And since we're interested in waves that are in a certain frequency range and in a certain amplitude range, we select the top 10% in terms of amplitudes per electrode for all these waves. And that allows us to select the highest amplitude wave, which will be defined as the local sleep events here. So as you can see, there is a certain level of arbitrariness in the definition of these local sleep events. This plot shows you the temporal profile of this wake slow wave compared to sleep slow wave. So you can see that the temporal profile is quite similar, although the wake slow wave have a number of differences. So they're smaller in amplitude, and they start with a higher frequency. So it's actually a mixture of delta and theta wave, which start with a theta component and then a down state. What's important here is this negative deflection here, because it's the one that has been associated with neuronal silencing in both sleeping and awake animals. We checked before the interruption how the modulation of these local sleep events, and we found that in mind wandering and mind blanking there were more local sleep than on task. This local sleep had a higher amplitude and were also steeper. So it's really all indicates that local sleep is a more pregnant phenomenon before lapses of attention. Since local sleep is defined at the electrode level, we can really try to predict behavior by detecting local sleep in a given electrode. So it's what we did here, where for each electrode, we looked at whether we could predict a certain behavioral variable with the presence of local sleep at the level of a single trial. So for each trial, we detected whether or not it was associated with local sleep events, and then we correlated that with a behavioral outcome. So you can see, for example, that in the case of misses, the presence of local sleep was positively correlated with misses in the back of the brain. So when sensory or associative areas are showing signs of tiredness, participants tend to miss more go trials, which contrasts with what happened with false alarms. So when participants wrongly respond to a no-go trial, this was actually associated with more local sleep toward frontal areas. And this makes sense in terms of the functional specificities of these different brain regions. If your frontal cortices go offline, you can imagine that you will regulate less well your behavior and tend to be more impulsive. If your sensory areas are going offline, you might encode less external information and be less likely to respond to a stimulus. And this frontal posterior divide was reflecting the reaction time, where in the reaction time, we see actually a positive correlation between occipital areas in the back of the brain and negative correlation with reaction time in the front of the brain. So again, this notion that local sleep in the front of the brain makes you impulsive and local sleep in the back of the brain makes you sluggish. And this was to a certain extent reflected also in terms of the phenomenology. So mind wandering compared to onset was associated with higher amplitude slow wave and steeper slow wave in the front of the brain, while mind blanking was associated with steeper slow wave in the back of the brain. These results were confirmed also by a modeling approach where we modeled the behavior on the task with a drift diffusion model, where we can extract variables such as the accumulation of evidence for go and no-go trial, the decision threshold, and so on. And what we observe is that the accumulation of evidence for the go trial, so how fast you will be to answer to go trial, was reduced when local sleep was observed in the back of the brain. This was also reduced, so it's positive, but the drift is actually negative, so positive correlation means a reduction here. So there was also a reduction of the accumulation for the no-go trial in the front of the brain, and overall a bias. The local sleep was able to explain what was reducing the bias toward go responses. So overall, what this result seems to show is that local sleep can predict attentional lapses and can predict it in a complex way, meaning that different types of attentional lapses can be explained by local sleep depending on where we observe local sleep in the brain. And the consequences of local sleep will be region dependent. So they will depend on which brain regions are impacted. However, it's important to remind that the local sleep in front and back of the brain are not do not only differ by their location, they also differ by their spatial extent. So local sleep in the back of the brain tend to be more expensive, and therefore could explain why it differs from local sleep in the front of the brain. And since Jonathan is now here, I can just conclude by saying that this work is available as a preprint.